simultaneous equations with fractions. Okay, so you can see in the first equation, we have a 5 over 3x minus a half y equals 12. And on the bottom line, the second equation is a quarter x minus 3/8 y equals 3. We don't particularly like fractions, dealing with them when we're trying to solve simultaneous equations. So the best thing to do is get rid of the fraction. This involves getting the LCM for the base fractions and cancelling out the fractions all the way across. So I'm going to start with equation number 1. When you think of the numbers 3 and 2, we're going to have to get an LCM for those. And also it's important to make the last number a fraction as well by putting it all over 1. The LCM for 3, 2 and 1 is 6. So I'm essentially putting everything over 6 and dividing everything into 6. 3 into 6 goes 2 times. And it's 2 times whatever is on top of that fraction, which is 5x. Then minus 2 into 6 goes 3 times whatever is on top, which is 1y, equals 1 into 6 goes 6 times whatever on top, which is 12. Okay, because we've used a 6 all the way across the line, the 6 cancels out. And we can simplify that line in one moment. We're then going to simplify line 2. Okay, so for line 2, the LCM for 4 and 8 is 8. Okay, putting the last fraction over 1. So 8 anyhow is my LCM. 4 into 8 goes 2 times, whatever's on top, which is 1x, minus 8 into 8 goes once, whatever is on top, which is the 3y. And 1 into 8 goes 8 times, whatever is on top, which is the 3. Because we've used the 8 all the way across the line and the equal sign, that 8 cancels off. We can then simplify both of these lines, and I'm going to do that to the right hand side now. The top line, we're going to start multiplying it out. Okay, so everything is going to be multiplied all the way across. And we're going to start now. So 2 by 5x is 10x. Minus 3 by 1y is 3y. And 6 by 12 is 72. Okay, so that's the top line simplified off. The bottom line we're going to do now. 2 by 1x is 2x. Minus 1 by 3y is minus 3y. And finally, 3 by 8 is 24. You treat these simultaneous equations like you normally would with any simultaneous equation. And we need to get the coefficients of either the x's or the y's the exact same. When we do that, okay, one of the variables will cancel and you will be able to solve for the other values. As you can see at the moment, the y values are the same coefficient. However, they won't cancel off just yet because we have 2 negatives. So minus and minus will give me minus 6y, but I want them to cancel. So I'm going to have to multiply one of the lines across by minus. So all of the signs will change. So that is plus, I'm changing it to minus. This is minus, I'm going to change it to plus. This is plus, I'm going to change it to minus. And at this point, the y's cancel, and I'm going to add down in the direction. So 10 minus 2 is 8x, equals 72 minus 24 is 48. Again, we're going to solve for x by getting rid of the 8, the coefficient in front. So that's x is equal to 48 divided by 8, which is 6. Now that I've got a value for x, I can sub back into the top line and solve for y. So you're going to say let x equals 6 and into the 10x minus 3y equals 72. So if x is 6, I'll have 10 times 6 minus 3y is equal to 72. So 60 minus 3y is equal to 72. Minus 3y is equal to 72 minus 60. Minus 3y is equal to 12. Okay, and I want to cancel off 3. So just quickly, to get rid of the coefficient, these are multiplied. The opposite to multiply is divide. So it's 12 divided by minus 3, which is minus 4. I've got my x and y value, and this is a coordinate, which I'm just going to write out to the left-hand side here. The x value is 6, and the y value is minus 4. Okay, and that's the point of intersection between both of those lines. And again, this is solving equations when you've been given fractions, and it's how to simplify the simultaneous equations into 2 lines that don't have fractions, and then being able to solve it afterwards.